Good evening, good evening, good evening, my dear J warriors. And it's time for revision, time for solving lots of questions. And what better than the best question bank that our own examiner, which is NTA, has given it to us. Yes, the previous year questions. And the best part is there are so many PYQs. I mean, J has been going on for more than 40 years, close to, and we have an amazing set of questions, and especially the last couple of years, which you need to focus on, plus some really good questions which have been asked in the last 20 years. Many times I've seen students only look at 1 year PYQs or just the last year PYQs. Well, that's a good strategy, but you never know what kind of questions are asked, and many times some old PYQ will repeat. Trust me, 20 years is not that old. So you need to focus on all these PYQs. And one of the most high weightage topics, and that's the mechanics part. So let's get straight away to mechanics. Best of the best PYQs which have been asked in the last couple of years. Good evening, my dear warriors. This is your Captain Shreyas. Hi Ragul, hi Sanjay, hi Afzal, hi Nikhil. Hi Nal, welcome Subha, welcome Darshan. Nice to see all of you. This is J Mains PYQs, not J Advance. Yeah. Hi Bensi, good evening, good evening. Vajra, Vajra, welcome Gauri, welcome Jay. Nice to see all of you. Yes, I hope you have smashed the like button. Yeah. Why I'm asking you? Because you'll just chuma watch it for free and go away. Where you will show your support? Where will you grow your J English channel? Where will you motivate us to make more such videos? So that's where you do it. Quickly smash the like button and also subscribe. Okay. Thank you very much. And also for those of you who were constantly asking me, sir, do you have JEE crash course in online and offline? Well, we have both. So the online batch is there in English. Still, you can join it. The entry point is there today. And it has all the crash material. It has DPPs, live classes, recordings, handwritten notes, a test series is included. It also includes JEE advanced preparation. All the topics are taught. Entire syllabus coverage is there. And the same thing is also there in offline mode. So both the links are there in the description box of this particular video as you are watching it. So just let me show it to you just in case you probably might give it a miss. So it's there right over here, as you can see. J crash course in English, this is online, and the offline batch, this is the link. Okay, so the online link is right over here, and the offline link is right over here, so that you can fill the form and take your admission or do the counseling part for the offline batches. There are many offline batches like in Pune, Chennai, Andhra Pradesh, Hyderabad Center, Vijayawada. So many places offline batches are going on. Cool. So let's begin with the PYQs, and here comes the first question on your screen. Good evening. Awesome. Yes, let's go. So first question, guys, coming up on your screen, and here it is. A particle is at x equals to 0, time is equal to 0, starts moving along the positive x direction with a velocity v such that velocity changes like this. The displacement of the particle varies as. Now, how many of you think this is a derivatives or integration question? Well, you can do it. One option that you have is that you can do it definitely via calculus method, via calculus method, where you think the velocity is nothing but dx by dt, and alpha is some constant, and this is root of x. So then you will just write this root of x is nothing but x raised to half. Take it on the other side, it will become x raised to negative half. Dx is equal to, take the dt on the top, alpha dt, and then you integrate this dt, and this is integration of x raised to negative half with respect to dx. You integrate and then you will come to the answer. But I feel that you should not do this method. You have to use a little bit of common sense. This is the standard procedure. Use little bit of common sense and you will understand that there is a small trick in this particular question. And what is that trick? Just square this. Just square this and you will understand what the trick is. V square is equal to alpha into x. Just write this as V square is equal to 0 square plus 2 into alpha by 2 into x. Deliberately I wrote it down in the third kinematic equation form. There is no damage done. There is nothing wrong in writing it like this. Quickly you can notice initial velocity was 0. 2 into this is done deliberately so that I get the 2as form. Acceleration is basically this one. So this is basically your acceleration. This is basically your displacement. This is basically your initial velocity. This is your final velocity. So that means acceleration is constant, and whenever acceleration is constant, the displacement is given by ut plus half a is nothing but alpha by 2 into t square. From this, clearly it is visible that the displacement is proportional to the square of the time. Displacement is proportional to the square of the time, and exactly that is the answer. Even if you do it over here, you will still get the same answer. But the problem with this method, that this method is definitely long. You will avoid it in the exam unless this was not in the kinematic equation form. Got it? Yep. I hope this is clear. Oh, sorry. I should have been alpha square. I'm so sorry. I did not square it. I'm so sorry. Alpha square, alpha square, alpha square. Okay. I'm just putting alpha square over here. I think I missed that alpha square over there. Yes. So cool. Loved it. Yep. Yes, this is good enough, Gauri, for mechanics revision. And then if you want to do second revision, obviously you can solve more PYQs, and there will be more problem solving sessions coming up. It's not the end of the story. Next question. There is a car which starts from the rest, accelerates at some rate, and travels distance s, travels with constant speed for time t, and then decelerates at f by 2 to come to rest. Total distance is 15 times of s. Then what is the relation between s and this particular thing? Yeah, this is somewhat like obsession J. See, obsession J will cover, like a little bit of concept plus the PYQs and different models. Here I am choosing the best of the best PYQs of many years, 20 years. When it is obsession J, it is the last 5 years. Then we can do many more models also. But I'm taking the best collection of PYQs because some PYQ models might not be so relevant or might be very casual or very easy. So that's the reason why I have changed the title. It's not obsession, it's like obsession. Okay, obsession is more I would say specific towards the last 5 years. With every model, like concept is cleared and then you solve that particular model. All right, so how do we do this particular question? First of all, let's draw the diagram and understand it. So you started from rest, of course, and till this point you had some acceleration at the rate of f, and from here to here you traveled at constant speed. Here it is constant speed, and then after traveling for constant speed, then again you started decelerating in the opposite direction at a rate of f by 2 until you came to a halt. It is clearly mentioned this time taken is t. This I don't know. Let's say I call it t1. One thing is very clear. If you accelerate with f, time taken is t1. If you decelerate at half the rate, then the time taken will be double. You are accelerating slowly. Obviously, time taken will be more. Making sense? Here, to reach the same speed, if I take time t1, from the same speed to come to a halt, but at half the acceleration, I will obviously take double the time. I hope this makes sense to all of you. I hope this is clear. Voice is low. Is it? Guys, just let me know if the voice is low or something. If that is the case, I will just change the mic maybe. Hmm. Okay. All right. Yes. I hope this is clear. I hope this is clear. All right. Now, what we can do over here, we can start using a little bit of kinematic equations. Just check, guys. Voice should be clear now. Yeah. Just one second. Yeah. Okay, so now what we can do is, it is mentioned that it continues at a constant speed for time t, and it accelerates through a distance of s. So this particular distance is basically s. That is also very clear. Okay, if this is s, can I find how much is this distance? I think we can do that. I think we can do that. I'll tell you how. For 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 the acceleration part, and let's assume over here the speed is basically v, that same speed will also be there over here. So for the acceleration part, can I say v square final speed square is initial speed square plus 2 into acceleration into the displacement, which is basically s. Therefore, v square is 2 times f times of s. Now, let's do it for the deceleration. For the deceleration part. For the deceleration part, check it out, the final speed is 0. So using kinematic equation, final speed is 0, so 0 square. Initial speed is v only, so v square. It is retardation. For deceleration, it will be negative 2 times f by 2 into that displacement in the third case. Displacement in the third case. Move it over here. So 2 times f by 2 into s3 will be v square, but v square is 2fs. V square is basically 2fs, and 2 cancel, so it will become f times of s3. F will cancel, so s3 will become 2 times of s. S3 will become 2 times of s. Great. So I have got this as 2 times of s. 2 times of s. One more thing which is given to me is this total distance. Total distance is basically 15 times of s. Total distance is basically 15 times of s is already given to me. I hope you can see that. 15 times of s, that is already given to me. All right. Now, one more thing which we can do, maybe over here for the acceleration part, somehow relate the times and maybe we can get something. Let's just try out different equations, guys. Let's just try out different equations. Nothing, no harm in doing that. This s displacement can be written down as ut, u is 0, plus half into acceleration is f into the time is basically t1, so t1 square, half a t square. Okay, so I can just write s is nothing but half into f into t1 square. I'll just keep it as it is. I'm not doing anything with it. This is one part of the equation. Now, maybe we should also concentrate on this distance, which I do not know yet. Maybe I should concentrate on this distance. Let's say I call it s2. Remember, this distance was technically s3, which we figured out over here. How can I write any equation for s2? It is going at constant speed. Oh, so when you are going at constant speed, there is no acceleration. It's just that distance is speed into time. It's just that your distance is nothing but your speed multiplied by the time. That's all. There is no acceleration. Distance traveled is s2. Speed is basically v. Time taken is basically t. V also I can write it. V also I can write it in terms of kinematic equation. I can write it as U plus A into T. T over here is T1. V is U plus acceleration into the time. So this into T over here. So what do I get over here? F T1T. So that is basically your S2. I have got S2. Okay, I have got S. Maybe I can divide both of them to see what do I get. Maybe I can just divide both of them and see what do we get from here. So let's say I call this as equation number A. Let's say I call this as equation B. And let's just divide this because FF will cancel, T1 will cancel. So A divided by B, what is it that I will get? Observe carefully. S divided by S2 will be equal to F T1 square divided by 2, and over here F T1T. FF got cancelled, T1 got cancelled. So 1 T1 is remaining, 2 times of T is remaining. This is S divided by S2. So therefore S2 will be equal to 2 times of T, 2 times of T times of S divided by T1. 2 times of T, S divided by particularly T1. I hope you can see that. I hope you can see that. But wait a minute. I know what S2 should be. If this is 15S, this is S, this is 2S, how much should S2 be? Think about it. It should be nothing but 15S minus 2S minus S which means minus 3s, which is nothing but 12 times of s. Perfect. So instead of s2, why not put 12s over here? This is 2t times s1 divided by t1. Oh, sorry, 2t times s, that's it. 2t times s divided by t1. Now s and s will get cancelled, 2 and 12 will get cancelled. So 6 is equal to t by t1. Therefore, t1 is nothing but t by 6. Once I get this time t1, I think I can put it over here. I can put it over here in equation number B. In equation number B, and I will get whatever etc. I want. If I put t1 as t by 6, so f t square by 6, I can get the relationship over here of s as well. So anywhere you can put it, even you can put it over here. Just check this out. In equation number A also you can put it. In equation number A, if you put it, s you will get it as half f into t1 square. Instead of t1 square, it will be t square by 6 square. Uh, yes, I hope you can see that very clearly. So it will be nothing but 1 by 72 ft square. 6 square is 36, 36 2s are 72. 36 2s are 72. Okay, I hope this is absolutely clear. So it involves lot of kinematic equations. Not every time just 2 or 3 equations will be enough. You have to just play around. I just went on playing with it, and you see, there is no way you can know that this is the flow. I'm just trying out different equations. Whatever I'm getting, I'm trying to keep it and see what I can do, mix and match, and see if I can get rid of the unknowns. That's all. You have to just experiment. You cannot just say, oh, I'm stuck here. Try different equation. Okay, I'm stuck there. Try another equation. Some way or the other, you will be able to eliminate all the unknowns. Always draw the diagrams. That helps a lot. Okay, here comes another question. I think it's motion in 2D, xy plane. Initial velocity 5j cap, moving with constant acceleration. Time t, the coordinates are this and this. Find the value of t and y naught respectively. Okay, so whatever I know, I'll just write it down. Initial velocity is 5j cap. Initial position is nothing but origin. Initial position is nothing but the origin. Acceleration vector is 10 I cap plus 4j cap. Final coordinates, the final coordinates, final position is 20 I cap plus some y naught j cap. Y naught is not known to me. Okay, what do we do? Wherever you know, solve that first. Whatever you know, solve that first. Which side do you know? Which component do you know? Which axis do you have enough information? I think it is the x-axis. As you can notice, if you solve it for the x direction, final displacement in the x direction is initial velocity into t plus half into acceleration into t square. I think I can use this equation. Final velocity I do not know. That's why I'm not using velocity equations. Nowhere over here I know the final velocities. So that's why I'm not writing anything to do with that. Final displacement, check it out, is 20. Initially it was at origin, so the displacement was 20 meters in the x direction. Initially the velocity was in the y direction, nothing in the x direction, so this will be 0 plus half. What is the acceleration in the x direction? It is a 10 multiplied by t square. Okay, 20 and 10, basically 0 0 cancels, 2 is equal to half t square. Therefore t square will be 4. Therefore t will be basically 2 seconds. Perfect. I can see 2 seconds here also, here also. So option A and option D gets eliminated. Now either it is this or this. So for that, let's do something in the y direction. How about using this same equation? How about using this same equation, but in the y direction? Sy is uyt plus half ay t square. Initial velocity in the y direction is given to be 5. What is the time that you are talking about? 2 seconds. Acceleration in the y direction is basically 4 and time obviously 2. 5 2s are 10 plus 2 cancels, 4 2s are basically 8. 10 plus 8 is basically 18 meters. So as you can see, 18 meters is right over here. So option B for IIT Bombay should be the correct answer. Very good, Nal. Bhargav, you have missed few questions, but that's okay. Yes, A, very good. Awesome. Awesome. Yeah. The roar series is done. Whatever topics are there which you feel that, sir, I need more information on, that part you can watch it on the crash course or the nurture and the pathfinder sessions. Okay. So otherwise, we are now on to the revision part. So that's the reason I told you about the crash, and the nurture pathfinder playlist is still there with all the other topics. A shell is fired from a fixed gun with some initial speed such that it hits the target on the ground at a distance r from it. T1 and T2 are the values of time taken by it to hit the target in two possible ways. What's the product of the times? What's the product of the times? Okay, there are only two ways to hit a target, means once you're going like this, the second time you might be going like this. Both the angles are complementary so that you end up getting the same range. Yes, the angles are basically going to be complementary. So if one is theta, then the other will be 90 minus theta. So I can just write that particular range will be, what is the range formula? What is the range formula? 2u square sine theta into cos theta, the whole thing divided by g. You can also write the range as 2u square sine 90 minus theta into cos 90 minus theta. So what you will notice is that if you write this, sine 90 minus theta will become cos 90 minus theta will become sine theta. So that's the reason why the ranges are same. Okay, fine, sir. I got this. Okay, I'll just keep the range over here as it is. I will not touch it. But the product of the times is asked. So what is the time of flight in the first case? It is 2u sine theta divided by g. If you ask me what is the time of flight in the second case, it will be 2u sine 90 minus theta whole thing divided by g, which is 2u sine 90 minus theta is nothing but cos theta whole thing divided by g. So let's do one thing now. Let's try to do t1 times of t2. T1 times of t2, because that's what they have asked. What is the product of the times? The first time is 2u sine theta divided by g. The next time t2 is 2u cos theta divided by g. What happens is, observe carefully now. Observe this carefully. 2 and 2 is there, u and u is there, sine theta cos theta is there, g and g is there. And if you see the range formula, it looks somewhat like this. Okay, so how about writing 2u square sine theta cos theta whole thing divided by g. What was left out is 1g, 1 2 and 1 u. This part over here is nothing but the range. So it will be nothing but 2u r 2u r divided by g. But I think we don't have to give the answer uh, in terms of, oh sorry, why did I write u separately? It was 2u square. There was no need of taking out u. My bad, guys. So sorry. This was just 2 by g. So this will be nothing but 2 by g multiplied by r. Yeah, u was already inside. U was already inside u square. So 2r by g. That's it. That is option number A. Yep, that's how you go about it. Loving it? Yes. Gina, like you can see the title, the thumbnail, mechanics. That's what the core focus is today. Right from kinematics, Newton's laws, circular motion, work energy, SHM, or collisions, rotation, center of mass. So these are the PYQs that we are doing today. Moving on to the next one. There is a disk which rotates about its axis of symmetry in a horizontal plane at a steady rate of some revolutions per second. If you place a coin at some distance and it remains at rest, what's the coefficient of friction? So let's imagine, first of all, a disk, okay, and it is rotating about some axis like this, and what you have done is you have placed a coin somewhere over here, and that distance is also given to you. That distance is also given to you. Let's say the distance is basically r. The mass of that thing is basically m. What are the forces which will act on that mass? Well, there will be one weight which will act downwards, which is mg. There will be a normal force which will act like this. A centrifugal force of m omega square r will pull it outside, but at the same time, the friction will pull it inside. If it has to stay at rest, obviously the frictional force will be balanced by m omega square r. So this is your static friction, which is balanced by your centrifugal force, and this friction is mu times of n, and n, as you can see, is balanced by mg. So mu mg is m omega square r. M cancels, and what is asked? Mu is asked. So mu will be omega square r divided by g. Now what is omega going to be? Let's see. 3.5 revolutions per second. You know what is this? Each revolution is 2 pi radians. So 3.5 is 7 by 2 revolutions per or rounds per second. So 7 by 2, each round is 2 pi radian. So these many radians per second, 2 cancels. So it is just 7 pi, which is nothing but 7 into 22 by 7 radian per second. 7 cancels. So it is 22 radians per second. Perfect. So omega is nothing but 22. Omega is nothing but 22. So 22 square, and radius, distance is 1.25 centimeters. So 1.25 into 10 to the power negative 2 meters, whole thing divided by g, which is nothing but 10. Solving this, you will get your answer. I think it should be almost like 0.6 or something like that. So this should be 0.6. This should be 0.6. Got it? Yeah. Loving it, Nikhil. Awesome. Tattva notes is good enough for final theory, Harish? Yes, no issues. Yeah, you can just stick to the Tattva notes. It's good enough. And whatever notes I have given you in roar and all of that, it's more than enough. You don't need more theory. You need more practice now at this last stage. Okay. Two cars of mass m1 and m2 are moving in circles of radius r1 and r2. Their speeds are such that they make complete circles in the same time ratio of centripetal acceleration. Okay, so both the cars have two different radius. The time taken are basically the same. So think about it. How is time related? How is their time related to their centripetal acceleration? Let's do one thing. Let's call this v1. Let's call this v2. Let's say both of them take the same time. This is radius r1. This is basically radius r2. I don't think mass will have anything to do with it. So the time taken is circumference divided by speed. Time is distance by speed. So circumference is 2 pi r1, speed is v1. For the other guy, it is 2 pi r2, and this is basically v2. 2 pi cancels. What this gives me is v1 by v2 is r1 by r2. How did I get it? Observe it carefully. This 2 pi and this 2 pi got cancelled. So v1 take it on the top, r2 bring it below. So v1 by v2 will be r1 divided by r2. Okay, once I get this, I can go to the next step, which is the ratio of their centripetal acceleration. Now, centripetal acceleration formula is nothing but velocity square by radius. Velocity square by radius. So acceleration 1 by acceleration 2 will be v1 square by v2 square, and this will be r2 by r1. Correct? Directly proportional to the square of the velocity, inversely proportional to the radius. But wait a minute, v1 by v2 is r1 by r2. So this is r1 by r2's square into r2 by r1. R2, R1, R1 cancels, and I'm left with just R1 by R2. So this is your A1 by A2. Centripetal accelerations ratio. Perfect. R1 by R2. So mass was chumma given. It was not at all necessary in this particular question. It was not a question on centripetal force. It was a question on centripetal acceleration. Don't get confused. Okay. And by the way, if you are loving solving all these PYQs and you want a physical hard copy book, let me remind you, there is a link which is there in the description box. As you can see, JEE PYQ books with topic wise arrangement, segregation, both numeric as well as single correct options, all questions included, all the 40 plus shifts of all the years. This is there in the description box. You can order your book and get it as soon as possible. Don't wait for more time. It's just there over here for 1999 rupees, along with the test series, along with the JEE mains plus advanced test series. Yes, it's not just the book plus the test series. And there is one hidden thing over here. You get free video lectures of all the topics along with this book. It is automatically given to you. You can scan the QR code and you will get all the details of the recorded classes of all the topics. So that content is also given to you. So check that out. Link is there in the description box. All right, moving on to the next one on your screen. A given object takes n times more time to slide down a rough inclined plane as it takes down a smooth inclined plane. What is the coefficient of kinetic friction? Okay, I think we'll have to do it 2 times. So I'll just create a duplicate. First time, just imagine it to be smooth. This is our mass. This will accelerate down, and that acceleration will be g sine theta. And let's say it covers a displacement of x and it starts from rest. Here, if it takes time t1, then I can say using s is equal to ut plus half at square. The displacement is x, initial speed is 0, acceleration is g sine theta. Theta over here is 45 degrees into time t1 square. Therefore, x will be equal to sine 45 is 1 by root 2. So g divided by 2 and this root 2 over here into t1 square. Okay, this is, let's say, equation A. I'll just keep it as it is. I'll just not touch it. Now let's do the next part of it. Imagine the same thing, but now it is rough. It is rough, and obviously the acceleration won't be the same. And when it falls down, the acceleration is g sine theta minus mu cos theta. Standard relationship which you should know. Same distance it is covering over here. Why does this happen? If you draw the free body diagram, it will become very obvious. One force downwards is mg sine theta, another is normal, another is mg cos, and friction is there, which is mu mg cos theta. So you can see the force will be mg sine minus mu mg cos. If you remove that m, you will get the acceleration. That's the reason why this is the value of the acceleration that you get. Okay, again using s is equal to ut plus half at square. Displacement is x. Initial speed was 0. Acceleration was this big thing, which is g, and then you have sine 45 minus mu, which I do not know, and cos 45 into time. Time is basically t2 whole square. Okay, so x will be equal to sine 45 and cos 45 both are root 2, so it will become g divided by 2 root 2, 1 minus mu, and this is basically t2 square. Wait a minute, I already know the value of x from here, so g t1 square by 2 root 2. Okay, so how about putting it from the previous slide? G t1 square by 2 root 2, and this is as it is, which is g by 2 root 2, 1 minus mu, and it is given to us that the object takes n times more time to slide on the rough plane, means it will slide down slowly, and this t2 obviously will be n times of that previous time, which is basically t1, n times of previous time, which is basically t1. This n is very important. It is given. It takes n times time as the one on the smooth. Okay, so what happens? as you can see over here, many things get cancelled. 2, 2, root 2, root 2, g, g, t1 square, t1 square. So actually, I'm just left with couple of things only, like on the right hand, sorry, left hand side, it's just 1. Right hand side, it's just 1 minus mu, and we have just n square, if I'm not wrong. Nothing else is remaining. Okay, so therefore 1 by n square is 1 minus mu. Therefore mu is equal to 1 minus 1 by n square. Perfecto. That is option B, which is going to take you to IIT Bombay. Awesome, Nal, Nalini A. Very good. Perfect, perfect. We have done some projectile motion questions also. I'm just taking some, it's like I said, these are, mixture of entire PYQs of last 20 years from mechanics. It's not just from one chapter, many chapters. Sometimes it might be mixed also. Okay, like you can see, this was kinematic equations mixed with Newton's laws and friction. So 3 concepts were involved. Beautiful question. Moving up to the next one. There is a block placed on a surface, cross section is given by this equation, friction is given. What's the maximum height above the ground for which the block placed will be there without slipping? This is a common question, let me remind you. So in these type of questions, first of all, let me just show the axis over here like this. The surface might be like this. This is y is equal to x cube. You want to find till what height you can actually place that block so that it will not slide. Think like this. If by chance I draw a tangent to the curve, it looks like an inclined plane. If I draw tangent here, it is less inclined. If I draw tangent here, it is more inclined. So the maximum height will be when the tangent drawn's angle, the angle drawn with the horizontal, is basically the angle of repose. This should be angle of repose. Think of this as an inclined plane, and if you increase the inclination, it will start slipping. The angle of repose is that angle after which the block slips, before which it stays there. So critical angle is the angle of repose. That is the manner in which you solve it. So I need alpha, so I can think of tan alpha first. So tan alpha will be the slope, and slope is nothing but dy by dx. The y over here is basically, where is it? This one. This particular y is nothing but x cube divided by 6. So when you take the derivative of this, 1 by 6 will obviously come outside. X cube's derivative is 3x square. So it will become x square by 2 is nothing but the slope, which is tan of alpha. But the whole point of angle of repose is that the tan of that angle of repose is the coefficient of friction, and the coefficient of friction is given to be 0.5, which means this left hand side is 0.5 and the right hand side is just x square by 2. 0.5 and half, it's one and the same thing. So what do I get over here? X square is just 1, therefore x is 1. Once I get x is 1, easily I can substitute the value of x over here. 1 by 6 times 1 cube, which means y is 1 by 6. So essentially this particular thing is your y, which is your height. This is your height, and the height is 1 by 6th of a meter. There you go. That's how you solve this. All these type of models of questions, very important. Again, I'm choosing all such questions which are very nice, conceptual, fun to solve, very likely, high weightage, all those important topics for your JEE. Yeah. Thank you. Life is beautiful. Yes, మీరు ఎలా ఉన్నారు? చాలా చాలా ధన్యవాదాలు. Life is beautiful. For all the students from Telangana and Andhra, welcome. Yep. Awesome, awesome, awesome. Yep. So moving on to the next question on your screen. An object is dropped from some height. Every time it hits the ground, it loses 50% of its energy. How much distance does it travel if you wait for a long enough time? That is t tends to infinity. Beautiful question. Seems like a difficult one initially, but when you start doing it, you realize a lot of few things. So let me show the ground surface over here. First time, imagine it drops from some height. Let's say it is h. If it loses 50%, just think about it. Loss of kinetic energy is 50%. This kinetic energy only gets converted into potential energy after the collision. So the potential energy which remains is also 50%, and potential energy is mgh. That means the height after the collision, the height after the collision is nothing but 50% of the previous height. The height after the collision is the previous height's 50%. So if it was dropped from h, the next height obviously will be nothing but h by 2. Oh, and when it again comes back, the next height will be half of that particular height. Oh, that's how it goes. So every height is half of the previous one, and it continues till it becomes almost zero. Now the real question over here is, what is the distance, total distance traveled? Okay, all right. I hope this is clear. Yes, I hope this is clear. This is basically the distance traveled once. The distance traveled. How do I find that particular distance? Well, see, if an object is dropped from this particular height, the first distance is h. The next distance is h by 2 plus h by 2. So 2 times of h by 2 plus next distance is 2 times of h by 4, h by 4, h by 4. Next will be 2 times of h by 8. Next distance will be 2 times of h by 16, and so on and so forth. Can you see which kind of series is this? Can you guys quickly think and tell me which kind of series is this? Yup. See, these are stupid students. Pardu heartbreaker. Waste fellow. You are not even a student, I think. Yeah. Concentrate. Coming here for promotion of some other institutes and all of that. What are you getting? Go somewhere else. You're not even a JEE student. Don't waste my time over here. Yeah. So this is nothing but a GP series, and this is a decreasing GP. You can simplify this. So this will become h plus h plus h by 2 plus h by 4 plus h by 8, and so on and so forth. Forget the first part. Just concentrate on this. This will add it later on. So this will be h plus h plus. This is nothing but your decreasing GP. So sum till infinity is a, which is the first term, divided by 1 minus r. Common ratio is half. Common ratio is half. So this will be h plus. This was the term in the bracket. This was the term inside the bracket. So this will be nothing but h by 1 minus half is half only. So this will become h plus 2h. So this will just become 3h. So the final answer should be 3h. Yes, that is the correct answer. I hope you loved this question. I hope you loved this particular question. Afifa, yes, I will be doing it for electromagnetism as well, this particular thing. And if you want me to do it, I want your support in terms of comments after the video. In the comments, everybody should put the next topic. Sir, PYQs of this topic. Sir, PYQs of that topic. We want it, sir. Let me know in the comment section. Number 2, I want everybody to smash the like button. If you have forgotten it, do it right now. Show your support. Got it? Only then I'll understand. Great. Next one, on your screen, particle of mass m is moving in a circle of fixed radius r such a way that centripetal acceleration given by this variable term, n and a are constants. Sorry, a is a constant, where n is a constant, sorry. Power delivered is how much? Okay, here we go. So it is going in a circular path. The radius is r. There will be obviously some centripetal acceleration. Well, there will be some velocity, and there will be obviously some centrifugal tangential force. So centripetal force will not give any power. So when you are talking about the power delivered to the particle, the power delivered to the particle, this power can be only given by the tangential force. That is very, very important. So this power is the tangential force into velocity. Power is force into velocity. That's it. So don't use centripetal force, because centripetal force is perpendicular. It cannot do work. This force can do work and can deliver power. That's why tangential force. All right. Now, what to do next? What to do next? How much is the tangential force? How much is the velocity? Nothing I know about it. So let me think. All right. So first of all, over here, centripetal acceleration is given by this. So let me just check what I can do. Centripetal acceleration is n square r t square. Acceleration is v square by r. So this is n square r t square. Therefore, v square is n square r square t square. Therefore, v is n r t. Wow, this is like PV is equal to nRT. Anyways, I got v, but I don't know force. No issues. Now think, what will be the tangential acceleration? It will be the derivative of the speed. So take the derivative of n and r are constants. So derivative of time with respect to time is 1. So it will just be nr, which means the tangential force, which is mass into tangential acceleration, will be m into nr. M into nr. Okay, fair enough. So the tangential force is m n r. The velocity, we just got it, is n r and t. So their product should give me the power. So power will be m is there, n square r square into t. M n square r square t, which is option A. Perfecto. What a question, guys. Veera level, love the question. Yes, awesome, awesome. What are the obsession series chapters? 11th. It depends. I mean, say Namrata ma'am is doing the obsession series. I'm not doing right now the obsession series. I've chosen mechanics top PYQs of last 20 years. Obsession series is for the last 5 years, which is super duper important again, because every model of the question is covered. Here we are doing the top PYQs. So that's why you will not see the heading as obsession. Okay, a wedge of mass m, 4m is equal to capital M, lies on a smooth plane. Particle approaches the wedge. There is no friction, and there anywhere the maximum height climbed by the particle on the wedge. Beautiful question. This is. This is a lovely question. Let's draw the diagram first. What might be exactly happening? Okay, so we have a wedge over here, and there is a mass which is coming, a wedge of mass capital M. Okay, so this is capital M, which is nothing but 4 times of M. This is just M, guys. This is just M, nothing else. Okay, it is approaching with some speed. How much speed? I think V. Okay, all this is at rest right now, but when it starts climbing up, then this will also acquire speed. It's not that the wedge is fixed. The wedge lies on a smooth plane. So even the wedge will begin to move. So even the wedge will begin to move. And with the small m, when it reaches the maximum height, when this particular mass reaches as high as possible, both of them will be moving together. Both of them will be moving together. There is no relative motion. Let's say the final velocity is u. Okay, so don't get confused. This is initial, this is final, and this is the maximum height which it has been able to reach. Did you understand? When they reach the maximum height, then there is no relative motion. That's it. It has reached maximum height. There is no further motion. So because of the initial momentum which was given to the small m, they have to still continue moving. You have to still continue moving. Is that making sense to all of you? Okay. So I think we can use conservation of momentum first. So conserve conserve the linear momentum, and you will see left hand side only this guy has momentum, this guy is at rest. Right hand side, this entire system 4m plus m is moving together with the speed of u. So mv is 5mu, therefore u is v by 5. This is one equation. Energy also is conserved, so let's conserve energy. So let's do energy conservation and see what do we get. Initial energy is half m v square. Final energy, both of them are moving together. So half into m plus 4m into u square. The total kinetic energy is m plus 4m. Speed is u. And this m has climbed up by h. So obviously it has got potential energy of mgh. This would be the energy equation. This guy's kinetic energy went into the system's kinetic energy, and the remaining was used to make this small m climb up. So this energy was utilized for two things. Okay, so let's see what happens. M gets cancelled everywhere, I believe. So v square is equal to, or v square by 2 is equal to, what do we get? M plus 4m, 5m, but m has got cancelled. So 5 by 2 u square plus gh multiply by 2. So v square is equal to 5 u square plus 2gh. Wait a minute. I know what u is. U is v by 5. So v by 5 whole square plus 2gh. So v square is equal to 5 square is 25. So v square by 5 will be remaining plus 2gh. Now multiply by 5. So you will get 5v square is equal to v square plus 2 into 5 is 10, 10gh. Take it over here. So 4v square is 10gh. Divide by 2. So 2v square is 5gh. Therefore, h is nothing but 2v square by 5g. 2v square by 5g. Yes, I can see option D over there, which is exactly what we want. Exactly. Yes, option 4. All right. All right. Cool. Awesome. Awesome. Let's move to the next question on your screen. If so many molecules of mass collide with a surface elastically per second over an area at this speed, the pressure will be how much? Somewhat related to kinetic theory of gases. First part, think if a single mass is going with a speed of u, hits a surface and reflects back with the same speed, because it is clearly mentioned it is elastic collision. What is the change in momentum of that particle? Final momentum minus initial momentum, which is 2mu, it is not 0. Direction has to be considered. So first direction, if it is positive, next direction is negative. So final minus initial, minus minus becomes plus. That is the change in momentum of one thing. And if it happens in time t, then the force by that particle will be the change in the momentum divided by the time taken. So it will be 2mu divided by whatever the time is taken. Now this is just by one particle. If there are n such particles, if there are many such particles, therefore the net force will be n times of each force, which means it will be n times of 2mu divided by delta t. But I don't want the force, I want the pressure. So pressure is nothing but, this is not small p, this is pressure, which is net force divided by area. So it is n 2mu divided by delta t divided by area. So this will be nothing but 2 times mu divided by a into n by delta t. Now everything is known to me. The mass of each particle 10 to the power minus 26, speed of each particle 10 to the power 4, area it is 1 meter square, number per unit time, how many molecules are there in this particular per second? Yes, 10 to the power 22. So this is 10 to the power 22 per second. It is given clearly per, per second. So the time interval is per second. Obviously, all the powers are of 10. So the answer should be 2 into something. In fact, it will be 2 Newton meter square. You can see that very easily. Newton per meter square. Yes, 2 Pascal or 2 Newton per meter square should be the correct answer. Yes, option D. Very good. A, null. Awesome. Very good, Raj. Very good. Awesome. Come on, guys. Keep answering in the chat box. Moving on to the next question. Let the moment of inertia of a hollow cylinder be this much. Inner and outer radius is given, and the I is I. Moment of inertia is I. The radius of the thin cylinder of same mass is also I. Then what is the value of that radius? Very interesting question. If you have a cylinder which is thick like this, if you have something like the thick cylinder over here, and this is the axis, then the moment of inertia is given by m by 2. Remember, for a solid cylinder it was mr square by 2, right? And for a thin cylinder it was m r square, that's it. But for a thick cylinder it is m r1 square plus, not minus, r1 square plus r2 square, whole thing divided by 2. That's the formula. Okay, now compare this with a just thin cylinder. Yep, remember this cylinder was having mass over here. Here it is completely empty. It's only the curved surface which is there. So this guy's moment of inertia is just mr square. Clearly it is mentioned the moment of inertia of this and this is the same. Masses are also same. So if that is the case, it is also I. That means this and this are the same. Even the mass is also given to be the same, of the same mass, you can see. Therefore, on the left hand side, r1 square plus r2 square by 2 is equal to r square. So therefore, r square will be, what is r1? First radius, inner radius 10, second inner radius, outer radius 20, whole thing divided by 2. 10 square 100, this is 400 divided by 2. This is 500 by 2, which is 250. So 250 is basically r square. So r will be root of 250. Remember, 250 is close to 16. So I think r will be 15.9 or something like that. So approximately 16 centimeters, not exactly, slightly less than 16. Yes. So approximately you can give the answer as 16, which is option number A. Got it? So this is a very important formula which you should know. Many people write it as minus here, which is wrong. And some people end up deriving it. No need, just remember it directly. r1 square plus r2 square by 2 into m. Okay, next one. A hoop of radius r, mass m, rotating with some angular speed is placed on the surface. Initial speed is 0 and it only has spin. What will be the velocity after it stops slipping? Very beautiful long question it is. It is not very simple also. Let me just draw the diagram for you. So this is that particular loop, and after it stops to slip, it has been initially given only the angular velocity. What is it? Omega naught. There is no translational velocity. And finally what happens? It begins to roll. It has omega and there is radius of that guy, and there is also velocity which is given by omega r. Now ideally this question cannot be asked in JEE Mains, but it can be asked in JEE Advanced. The reason I will tell you, because rolling is as such not there in our JEE Mains syllabus. Rolling deep concepts are no longer there. So that is the reason why this can't be a mains question, but it can be a advanced question. I'll just tell you an idea about how to solve it, okay, so that you get a clear understanding of the different concepts involved. First of all, because it is only spinning, the bottom part goes behind. So there is a force at the bottom, which is the force of the friction. So kinetic friction is here because of the force, and other forces are just normal and obviously mg. This force will cause an acceleration in the forward, and this force will create a torque in the backward direction. So angular acceleration becomes retardation, and linearly it will accelerate. So basically, angular speed reduces because alpha is opposite, whereas linear speed increases till velocity becomes omega r, because this is the point where it is rolling. This is the point where it is rolling. That's all. Now you just have to write the equations and you will get it. First of all, how much is the kinetic friction? It will be mu into n, but n is mg, so it is mu mg. So if you write it for the translational part, since the net force will be mass into acceleration, kinetic friction will be mass into acceleration. Kinetic friction is mu mg is equal to ma, therefore acceleration is mu g. Also we can write one more thing. Final velocity is initial velocity plus acceleration into time. So final velocity is mu g into t. So this is one equation which I get over here. Okay. Now let's do the similar thing for rotation. Net torque is I into alpha. Torque is R into the kinetic friction. Moment of inertia of a, what is it? Hoop. Hoop means it's a ring. Hoop means basically it is a ring, and for a ring the moment of inertia is just m r square. Alpha is not known. I'll find it out. So one of the r gets cancelled, or we'll just keep it for now. Kinetic friction is mu mg. So mu mg is equal to m r square alpha. Cancels, r cancels. So alpha will be mu g divided by r. Okay, keep this as it is. Now use final angular velocity is initial angular velocity plus alpha into t. Final velocity omega, initial velocity omega naught, but it is retarding because alpha is opposite. So technically it should be minus. Alpha is mu g divided by r into the time. Okay, what next? Well, v is omega r, or basically I have to get rid of, what do we have to find? Initial, what will be the velocity we have to find? Okay. I can get rid of the time from here to here. That's one thing I can do. All right, and shift it over there. All right, so we'll do one thing. Omega plus mu g divided by r into t is equal to omega naught. Next step, omega is nothing but v by r. Just check this out. This particular omega is nothing but v divided by r. Okay. Also, what do we have next? Time, right? So mu g divided by r. This time is v by mu g. This particular time from here is velocity by mu g. Okay. This is equal to omega naught. This is equal to omega naught. Perfect. So mu g cancels, and we just have now omega naught is equal to v by r plus v by r. So 2v by r is omega naught, which means v is equal to 2 omega naught. Sorry, it is nothing but omega naught r divided by 2. That should be the answer, which is right over there as option number C. So Newton's laws, rotational motion, kinematic equations, and this was the only concept of rolling involved. Other than that, other things were pretty much straightforward. Okay, I hope this is clear. All right, moving on to the next questions. The mass and the diameter of a planet are 3 times the respective values for the Earth. Okay. Period of oscillation of a simple pendulum is 2 seconds on Earth. The period of oscillation on the other planet will be. First, let's do for the Earth. For the Earth, the time period is 2 pi root of L by G. Length has not changed. Gravity will change on the other planet. And what's the formula for acceleration due to gravity? The formula for acceleration due to gravity is nothing but, check it out, the acceleration due to gravity, G is equal to Gm by R square. So if you go on the other planet, now on that other planet of some other planet, the mass is 3 times, the diameter is 3 times. Okay. Now on the other planet, G prime will be G, mass is 3 times, so 3m. Diameter is 3 times, so radius is also 3 times. So 3r whole square. So this will become G 3m by 9r square. So this will become Gm by 3r square. Gm by r square is G. So it will be nothing but G by 3. So the new gravity is G by 3. Okay. So what's the new time period? T prime 2 pi root L by G prime. So 2 pi root L by G prime. What is G prime? It is G by 3. Put it on the top. So 2 pi root L by G. Root 3 will go on the top. This whole number is the original time period. So our T prime was the time period on Earth. So the new time period is T times of root 3. But T was given to be 2 seconds. So 2 into root 3 is your T prime. So 2 into root 3 is the new time period, which is option number D, of course, and that is correct. What a beautiful question. Yep. Very good. Awesomeness. Moving on to the next one. Oh, wow. We have an oscillator. Equilibrium position, energy, potential is half K x minus x whole square. See, don't get confused just because it is x minus x. At the end of the day, the spring potential energy is half K x square. But if you choose a different point of origin, then the shift of origin formula will be x minus a. So basically, you just shifted the origin. It's like a spring energy only, half K x square. Just keep that in mind. Shift of origin is involved. That's okay. Fair enough. Maybe the natural length is not at x equals to 0. It is at some other point. That's all it means. So the equilibrium is at not at origin. The particle of mass m comes from the right side, collides with it inelastically, and gets stuck to it. This process repeats every time it crosses the equilibrium position. The amplitude after 13 oscillations, this was asked in JEE 2018. Maybe it's a lengthy question because 13 oscillations are involved. Let's see how it goes. Okay, so oscillator of mass m is at rest. So this is our mass m, and right now it is at rest. What happens is, from this side there is a mass small m which is coming and hitting with some speed. Yes, the speed is also given, u. Okay, once it gets stuck to it, okay, this whole system as a whole will start having a momentum this side. The initial momentum, if you ask me, what is the initial momentum of that system? The initial momentum of the system will be 0 minus mu. It's going to the left side, so it is just minus mu. The final momentum will be nothing but m plus m into some velocity, and these both should be equal. So obviously the final momentum should also be minus mu only. Initial momentum should be final momentum. Momentum is always conserved in a collision. Okay, so the momentum is like this. Okay, great. The process repeat every time it crosses the equilibrium. So what happens is, this mass goes over here and takes a U-turn and comes back again to its equilibrium position over here, and this mass is still attached to it, and then from the other side a new mass comes with this speed like this. Observe now what will happen. This guy has this momentum, but now reversed. So the momentum is mu. From this side, the momentum is mu. So when they attach to each other, mu and mu, total momentum, what do you think will happen when they get stuck? Both these masses are stuck. What will happen to the net momentum? The net momentum, the net momentum will be zero. That means it will come to a halt. So it will be at rest. Brilliant this is. This mass comes and hits it, gets stuck, zoop, it goes, stops, comes back. When it comes back, another mass comes, gets stuck to it, it stops. Now another mass will come, thuk, it will go hit, it will go there, and when again it comes back, again it will stop. So every eventh collision, it will stop. Agree or disagree? Every eventh collision, what will happen? Yes, it will stop. Correct. Oh, so every eventh collision, it stops. Perfect. These are 13 collisions. So what will happen after 12 collisions? After 12 collisions, let's think about it. This particular mass m is there, and you have 1 2 3 4 5 6 7 8 9 10 11 12. So 12 such masses. So the total mass, so the sorry so the total mass will be m plus 12m, which is 10 plus 12 multiplied by 5. 12 5s are 60, so this will be 70. So 70 kg is the mass after the 12 collisions. After the 12 collisions. Last session's timetable, Hari, have already uploaded it on the Telegram. I've also put it up in the description box. If you have not seen it, please see it. It's there. It's right over here in the videos. Go to the GOAT strategy. And where is it? Where is it? Session PDF. Yay! It's there. Session PDF is right over here. So go check it out. All right. Perfect. Okay. Now comes the next mass, and let's see what happens. Now comes the next mass, and let's see what happens. So this is our original mass 1 2 3 4 5 6 7 8 9 10 11 12, which is having a total mass of 70 kg. It is at rest, and from this side you get this small m, which is of 5 kg, which is going to travel at u is equal to 1 meter per second. When it collides, this particular combined system will now have 13 masses 1 2 3 4 5 6 7 8 9 10 11 12 and 13. Yes, 13 masses are there. So total mass, what will be the total mass? 5 plus 70, that will be 75 kg, and this will be having a new velocity or a new kinetic energy over here. Is that making sense to all of you? It will definitely have a new velocity over here. So if I apply conservation of momentum, what will I get? If I apply conservation of momentum, what will I get? Initial momentum will be 0 plus mass into velocity, which is 5 into 1, is equal to final momentum, which is 75 into v. Therefore, velocity will be 70, guys, 15 times. So 1 by 15 meters per second. Once I get that, I have to make use of this fact because the question is amplitude of oscillation. I know whatever this is, this will be the kinetic energy at the mean. This will be converted into the potential energy at extreme. Therefore, the kinetic energy will be half into total mass, which is 75, into velocity, which is just 1 by 15 square. This will be equal to spring potential energy, a half k is 1, into the amplitude square. Half will get cancelled. You will get the value of A, guys, right from over here. And how much will it be? Check it out. Come on, my dear students. How much will be the amplitude? Yes, 1 by 15. This is 75, which is 25 into 3. So this will be 75 by 15 square. So A will be 75 is 25, which is also 5 square multiplied by 3 by 15 square. So this will be 5 root 3 by 15, which is root 3 by 3, which is 1 by root 3, which is 1 by root 3, which is option A. Yes, perfect. What a question. What a lovely question. Good evening, billionaire. Vanakkam, Savarish from Tamil Nadu. Yep. Not sure, Shubh, how many questions, but as many questions as I feel necessary. Oh, I think we are reaching the last question. Okay. If Earth has no rotational motion, the weight of a person on the equator is W. With what speed the Earth should rotate so that the weight will become 3/4 of the weight at the equator? The radius of the Earth is 6400 and G is also 10. Now, there is a direct formula which you can use it, and that goes like this. The apparent gravity due to rotation is original gravity G minus omega square R cos square lambda. Now, this lambda over here is the latitude, and the latitude at equator is basically 0 degrees. So cos 0 is 1, cos square of 0 is also going to be 1. So therefore, I will get the apparent gravity is G minus omega square R. So multiplying by mass, this will become apparent weight is the actual weight minus omega square R into M. Okay. So, all right. So this is also given. Now, I do not know the mass of the person. So I can do one thing. Mass can be written down as, since mg is weight, so this will be weight divided by g. Why did I write it like this? Observe again. The weight will be mg, therefore m will be w divided by g. So that's why this particular mass over here, I have written it down like this. Perfecto. So therefore, next step, it is mentioned that the person should weigh 3 by 4th. So the apparent weight is 3 by 4 times of W is equal to W minus W omega square R divided by G. Best part, W got cancelled. W got cancelled. What do I get? So 3 by 4 minus, sorry, is equal to 1 minus omega square R by G. Therefore, omega square R by G is 1 minus 3 by 4, which is 1 by 4. But the question is what omega is there? So omega square will be G by 4R. So omega will be G by 2, sorry, 1 by 2 root G by R. Now substitute everything over here. G value and R value. G value is how much? 10. And R value is how much? 6400. So 6400 into 10 to the power 3. Solving this, you will get the value of omega. Got it? So the value of omega comes out 0.63 10 to the power negative 3 radians per second. So solving this, you are going to get option C. So this formula was very important, which is the apparent weight formula, because of the centrifugal force due to rotation. It depends from place to place. Centrifugal effects are maximum on the equator, 0 at the poles. So the latitude of the place matters. On the equator, the latitude was 0. Apparent weight was 3/4 the original weight. That's why W got cancelled. Here, mass was not given. So I wrote mass as weight by gravity. That helped me cancel W. And then rest was simple mathematics. Okay, so that's how you solve this particular question. And I hope you loved this particular session. What we do, yeah, you have learned that session, formula and row series. how to make solving questions fun. Solve easy ones first. Understand what is the hidden meaning. Don't just go to the next question. Always see what the examiner wanted to check in you. Don't just solve it. Don't just practice it. Go deep inside it. Understand the hidden meaning and play with it. What if whatever is given is asked and whatever is asked is given? Solve it reverse. You will get a new perspective, new dimension. Try it with all the simpler questions, explore it, then go to the average, below average questions, then go to average questions, and then go to PYQs. That will make it fun, because when are you going to have fun? When you know how to do it, or you feel that you can do it. When you think that you can't do it, you can never love it, no matter how interesting it is. Somebody might be interested too much in, maybe let's say, English songs, but then let's say you're not able to hum it, let's say you don't remember the tune, then you will never love it. Let's say you are not able to play an instrument, then you will never like to, you know, uh, play for someone, or probably you will not be so much interested in music. But let's say you understand a little bit about music, or you are able to sing along and stuff like that, you're able to recollect the lyrics. That's when you enjoy the song or enjoy the music. That's how it is. So always make sure you are comfortable in solving problems. Don't have to go to the hardest of the hardest question. Make yourself comfortable. That's when you are going to love solving whatever you are doing. And that is very important. What you asked is a very genuine question. You should always have fun while solving. So I hope you enjoyed today's class. And wherever you got stuck, please replay that part. Leave a comment on what topic you want, or should I do an obsession on some particular unit. Okay, do let me know in the comments. All the best, and do not forget, the link for the crash as well as for your offline crash is there down in the description box itself. So go down as you're watching this particular video. Yep, go down as you're watching this particular video into the description box. Yep, you can see the crash course online is there. This is the offline batch. If you are interested in the PYQ books along with the test series, along with the free video content lectures, recorded ones for 1999, that link is also right over here. All the things mentioned down there. All right, all the best. Take care. I'll see you very soon. Bye bye.